In the last class on trigonometry, I discussed complementary angles and how to use sine, cosine, and tangent formula in a right-angled triangle. Today, we want to solve some problems using this knowledge. Now, this is a question on the board. We are given the three sides of the triangle and we are asked to find the angles. We want to find the angles. That means this angle, let me call it alpha. This one, let me call it beta. Okay, how do we find alpha and beta? Fine. Remember our SOHCAHTOA. Yeah. So this is what we are going to apply. If I want to find alpha, and I want to use this side and this side, that means this will be opposite, this will be adjacent. Okay? And if I want to use these two sides, this will be opposite, this will be hypotenuse, based on the previous knowledge on the previous video. In the previous video. Okay. Now, I would like to use sine. Sine alpha will be equals to opposite over hypotenuse, which is something as vertical here over hypotenuse, which is horizontal. So that means sine alpha will be equals to 5, which is the opposite, over hypotenuse, which is 13, because that is opposite over hypotenuse. So that will give us 0. What? 5 over 13 will give us 0.3846. 3846. Then how do I get this alpha from here? So alpha will now become inverse of sine of this, inverse sine of this value, 3846. That means we check the second function of sine of this value, and that will give us approximately 22.5 degree. That means this angle is 22.5 degree. Now, I want to find the second angle, which is beta. I may decide to use SOHCAHTOA also, but as we all know that timing is very important, so you have to be very conscious of time in any exam you write. So what do you do instead of going through that? Since the sum of angles in a triangle is 180, and from the previous class, previous video, I said that these two angles in a right angle triangle are complementary. That means I will use that knowledge of complementary angles. That is alpha plus beta from the right angle triangle. Please do not misquote me. In any right angle triangle, the two other angles aside that angle 90 are complementary. And that means when you add the two together, it will give you 90 degrees. So since I know that, and I've gotten one of the two, then I can easily say that 22.5 plus beta is equal to 90 degrees. So by shifting this one to this side, beta will be 90 degrees minus 22.5 degrees. So, and what will now be beta? That will be 67.5 degrees. That will be the angle, the second angle. If you had used any of the SOHCAHTOA, sine, cosine, or tangent, you will get the same thing. Alright, this is another example. We are asked to find x and y in this diagram. Are you listening? Okay. when you look at this whole triangle, you will notice that we have two different right angled triangles. Let me show you. This is one sign for angle 90. It's another sign for angle 90. That is it. Okay. Now, the bigger right angle triangle is triangle ABC, where angle A is the right angle, which is 90. So that means I know 90 degree, I know 65 degree, which is angle B. I can know angle C, because sum of angles in the triangle is 180. That means angle A, okay, in triangle ABC, which is a right angle triangle, angle A plus angle B plus angle C equals to 180 degrees. So angle A is 90 degrees, angle B is 65 degrees, then plus angle C we are looking for equals to 180 degrees. By the time you sum these two, you get 155 degrees. So transferring this one to this side, you will be getting your angle C to be what? 180 minus 155 degrees. And that will give us what? 25 degrees. That means this is 25 degrees. Now, having gotten this, let's now check which of X and Y can be easily found first. Of course, that is X. You know why? Because this side Y is within angle ADC. Right angle triangle ADC. And if you look at right angle triangle ADC, this is the only thing we know there. We don't know this side, we don't know this side, we don't know this side. So we don't have much information to work with. But if you look at triangle ABC as a whole, you see that side X is facing angle B. That means this is opposite to angle 65. Side 4 is facing angle 25. That means this is opposite to 25. So, how can I decide which one I should use? Either this or this. Well, I will give you one secret. I would rather use 65 instead of 25, though I will get the same answer. But prevention, they say, is better than cure. Let us assume that while I was finding this 25, I had made a mistake unknowingly. So if I go ahead and use this 25 in my subsequent calculation, the error will be carried over, and that means everything will be getting wrong. I mean, everything I will be getting will be wrong. You understand now? So in that case, it's better to take precaution and use what you are given in the question originally. So I'm going to use angle 65 now. So if I use 65, this in triangle ABC. In triangle ABC now, B to C will be the hypotenuse to A. I mean, to the triangle, because it's the one facing angle 90, which is angle A. That means 65 is facing here. This will be opposite. And this 4 will be adjacent, since the whole of here is hypotenuse. So opposite, adjacent. That means tan 65 degree will be opposite, which is AC. AC over adjacent, which is AB. So tan 65 degree will now be, what is AC? That is X, over what is AB? That is 4. So by the time we cross multiply, that means X will be equal to what? 4 tan 65 degree. By the time you look for tan 65 degree and you multiply by 4, what do you get? You get 8.58 approximately. 8.58 centimeters approximately. So I've gotten my X. 8.58 centimeters. Now, to get Y, since Y is part of B to C, that means I would rather want to find BC, which is the hypotenuse. in triangle ABC. You are still in triangle ABC. That means to find this hypotenuse side BC, I will use 4. I won't use this in case I had made a mistake in finding this, so that it will not affect. Like I said, it's just a precaution. But if there was no mistake, that means it will be correct. But let us take precaution. So that means this is hypotenuse, this is 65, opposite, this will be adjacent. That means cosine 65 degree, which is adjacent over hypotenuse. And what's adjacent? 4. What's hypotenuse? B to C, which is BC, from here to here. The whole of this is the hypotenuse of triangle ABC. So BC will be 4 over cosine 65 degree. And when you check for that value of cosine 65, so by approximation, BC from here to here will be 9.47. So I can now get Y. How would I get Y? I will get B to D from here to here. When I get B to D, I will subtract it from this. So it will now give me D to C, which is Y. So that means to get B to D here, I'm restricting myself to triangle ABD now. In triangle ABD, this side will be adjacent, but this will be opposite. This side will be opposite, this will be adjacent, and this hypotenuse. That means adjacent hypotenuse, which is cosine also. So that means cos 65 will be BD over 4. And the BD now will be equals to 4 over cos 65 degree. And what would that give us? Approximately, that will give us 1.69 centimeter. Now, Y will be equals to BC minus BD. BC minus BD. And what is BC? BC is what did we get for BC? Yes, in the previous we got 9.47, right? 9.47 minus 1.69. What would that give us? 7.78 centimeter. So that's the end of that. So in the next video, which will be episode 3, I'm going to deal with trigonometric equation in which we apply knowledge of complementary angles also. Thank you.